Hello, this is Mr. Zanetto. I'm going to go ahead and go over that first page of topic scheduling day 1. And what we're doing here is we're looking at vertices and we're naming their degree. So for A, degree is 1. There's only one edge going to it or going from it. And in fact, this is an in degree, so we put 1 in the in degree, 0 on the out degree because you can't go out from it. Incident 2. You can't go to anything, so that's crossed out. But incident from, you could have come from, if you're at A, you could have come from B based on the edges that we know something about there. So there we go. That's how you list that first one. If we look at B, at the other hand, there's a degree of 3. 2 coming in and 1 going out. You can go to, from B, you can go to A, incident to A, but incident from, you could have come from E twice. Both degrees from were from E. The next, C has 2 edges. 1 in and 1 out. If you're at C, you can go to F, but if you're at C, you could have come from E. D, that's degree of 1. It's going in 1. So you have no out degrees. You can't go to anywhere from D, so that's out. And incident from, if you're at D, you could have come from E. Now E has 1, 2, 3, 4, 5. Has the largest degree. It has 1, 2, 3, 4, 5, but they're all going out. So you have degree of 5. They're all going out. You have 0 in degree. And then from there, your incident 2. If you're at E, you can go to D. You go to B, 2 different paths or edges. You can go to C, or you can go to F. And there is no way you can come from somewhere to get to. And then the last one is F. F has a degree of 2, both coming in. So that gives you a 0 out degree. You can't go to anywhere from F, but you can go from F. You could have came from E or C. Draw a digraph using the following information: A, B, C, D. A is incident to B and C. D is incident from A to B. That last part is probably the most confusing thing on these notes, I believe. A is an incident to B and C. That's pretty easy. You can go ahead and just go. A can go to B, or A could have gone to C. D is incident from A to B. Really what they're saying is D is incident to B. So there's D. So A is incident to B, A is incident to C, and B is incident to D. I'm sorry. It says D is incident from B. And then you sort of skip over this A because really that's just saying from B and A to B. So that's how they're linked. That's it. So again, I would say that right here, this part is probably one of the more confusing ones. Remember, if it's incident from A to B, then it's really incident from B. So D is incident from B. Good, we got it represented. Okay, now from there, from this whole idea that A is incident to B and C, D is incident from D. Now, A is incident to C and E. B is incident to D and E. C is incident from D and E. D is incident from C and E. There's no 2's, so that those aren't going to be as confusing as what we just had a minute ago. Let me go ahead and make over here a larger, I'm going to make a larger path here. A, B, C, D, and E. So if A is incident to C and E, I can draw that very easily. A incident to C and A is incident to E. B is incident to D and E, so I'm going to go from B to D and B to E. And then I have C is incident from D and E. From D and E. So that's from is going to throw me off a little bit. I need to go backwards. So it's from D to C. From D to C. And from E to C. And then the last one, D is again from C and E. D is from C and D is from E. There. Now, when I look back at some of my notes earlier, I'm really glad I went over this, and please make note of those froms are so distracting and actually make you go the opposite direction. Make sure you do that. Where when you see 2, incident 2, it's just what you thought. A to C, A to E, B to D, B to E. So those you just sort of blow through. But that, what I highlighted in yellow is a caution. Make sure you go from that. And in fact, I would make sure that I may end up pulling off that class one, because that class one I went over it and I was actually going the wrong direction. Make sure that from changes your order, so be careful of that. Okay, so after that, now we get number 3, and number 3 I think is much clearer. Find a path from A to F. A path A to F. So we're going to start at A, and we're going to go to B because that's the only place we can go. And then we go to D, and then to E, and then to F. That would be a path, starting at A, going to F. Let's go to B. B is a Hamilton path, same thing, except now we're trying to hit all those vertices. So we're going to go A to B to D to E. Now we need to pop up to C, so we include it, and then we go to F. So it says that this could have also been your answer for the path, but you have to include all the vertices since it's a Hamilton path. Find a cycle in the digraph. A cycle. There's a couple of cycles I might suggest looking at, but the easiest one I would say would be E. Start at E, go to B, go back to D, go back to E. Start and end in the same place, that's a cycle. You could have done any of those with regards to that, but I think that's the only real cycle that we have, and we can start at any one of the 3 points and go around. Explain F cannot be part of a cycle. Well, F cannot be part of a cycle because F, to be part of a cycle, you have to have an in and an out. And there's only ways to go into F. So explain why F cannot be a cycle. Because F has no edges leading out. And explain why A cannot be a cycle, because it has no edges leading in. And that is the front page of the packet. I'll be back with the other two. Thank you.